Welcome to Module 4, which is RAG, Practical RAG, Retrieval Augmented Generation, and Context Engineering. In this first lesson, we're going to do something critical before writing any serious code. We're going to design the blueprint. We're going to understand it. Because here's the reality. Most failed applications don't fail because of the model. They fail because of poor architecture. And by the end of this lesson, you should be able to confidently sketch a complete RAG pipeline, from the user queries to the vector search to the augmented prompt, and understand exactly where things can go wrong. So let's take it a notch further. Imagine you're building an internal support assistant, like I've said, for staff, like usually, let's say a fintech client. Now they have thousands of documents, lots of compliance things they shouldn't go wrong, rules, policies, onboarding guides, API documentation, support tickets. Now your job is to build like an AI assistant that answers like a question like, what's the KYC verification flow for EU customers? Like a member of team is asking. Now, if you just use a base LLM, you get a generic answer from many of the models, which is decent enough, maybe from Claude or from OpenAI. It will even be confident, but it might be incorrect. And this is not acceptable in production because there are some nuances that are based in different countries, different areas, even different companies. So instead, you're supposed to implement RAG, or Retrieval Augmented Generation. Now your system is going to search internal documents for your company. It's going to retrieve the most relevant sections to the query the staff is asking, and it's going to inject them into the prompt and then send them to the model. Okay, then you get a grounded answer from the model. So this is the difference between a chatbot that sounds smart and a system that is actually useful, is accurate, is practical, and trustworthy. As engineers, that distinction is everything. So this is not just another hello world, oh, it works. No, you really want to build something that's trustworthy. All right, so high level, let's break down the architecture. A RAG system has two main phases. You're going to encounter two main phases. The first is the indexing phase. This is where you prepare your data. You take raw documents, which will be PDF or PDFs or docs or database information for the company. You're going to split them into chunks, and then you're going to convert those chunks into embeddings. We touched this a bit. And then you're going to store those embeddings in a vector database. Think of it as you're building your searchable knowledge layer. Okay? Now the second phase, which is the runtime, that first one is the preprocessing. This is what happens when a user asks a question. So what normally happens, the user sends a query, what is this for like an EU customer? And then that query is converted, that the user sends is converted into an embedding. Now your system performs a similarity search in your vector store. You're comparing the similarity between the embedding from the user query and the ones already existing in your database, in your vector database. So once you do this similarity, then you retrieve your most relevant chunks. You inject them back into the prompt. You send that to the LLM, and then you get a nice pipeline. And a beautiful answer. That's your pipeline. Okay, it's of course it's simple, but there's a lot in the details. Quickly, let me zoom into the components. Chunking. If your chunks are too big, you're going to lose precision. Your chunks are like how you break the text into different parts. Now, if they are too small, again, you lose context. So you need to be able to, this is one of the most underestimated parts of RAG when you are an AI engineer. So you must chunk properly. Now, the second one is your embeddings. You also have control over this. This is how your text, of course, become vectors, which are numbers. Your embedding model defines how meaning is represented. Bad embeddings leads to poor retrievals, which are going to give you bad answers, inevitably. Your third aspect is your vector store. Now, this is your retrieval engine. this is like your database, but instead of exact machines, it does that mathematical semantic similarity search and comparison like we spoke about. And the fourth one is the retrieval. You don't just want any kind of results, you want the most relevant results. So there's something called your top K search, and then filtering and ranking comes in based on that top K, or most relevant in simpler English. And then and then the fifth one, you're going to have prompt augmentation, which is where many engineers also make an issue. You're not just dumping the text into the prompt, you're structuring it in a way that the LLM and the transformer can reason over it. We talked about this earlier on in module 2. So now, key things I want you to keep in mind, note this down, so it's going to be in the cheat sheet to save you weeks of debugging. Here are some common reasons why RAG systems can fail. Retrieving irrelevant chunks, that's the first thing. Avoid this. Avoid also missing the critical context, what really matters. Avoid poor prompt structure. Avoid overloading the model with too much data. That's why we have chunking in the first place. You don't just send everything. And then if you are not evaluating, if there's no feedback loop to check if this makes sense, there's going to be, just keep those 4 things in mind. Because if you don't evaluate, even when there's a failure, everybody's confident and then you confidently say rubbish, okay? So you need to think like a system, engineer, not just a coder, okay? The goal is to make sure you have a strong mental model of how all this RAG system works, from indexing data to retrieving context and to generating grounded responses, because your understanding of this is the foundation for everything that follows, because you're going to build your own application. So it's important that you fully understand it. All right, see you guys.
Thanks for watching.